Hello and welcome to Quadrant and Angle Terminates. Woo! Okay, so when I'm talking about quadrant and angle terminates, I'm really talking about the trig ratio that the angle terminates, like the value of the trig ratio at that moment. So if you would, get your calculators out, pause it if you have to, and evaluate each one of these guys to 4 decimal places or to the 10,000ths. Okay, so 4 decimal places. Each of these 6. Pause it, do it, come back. Okay, the sine of 120 is positive 0.8660. The cosine of 120 is negative 0.5. So since I did say 4 decimal places, there you go. The tangent of 120 is negative 1.7321. Okay, those are pretty straightforward. You just type sine and 120 in your calculator. Now, if you're not getting these values when you're doing this, if you get something crazy, well, okay, or something that isn't exactly that, please make sure you're in degree mode. That means you go to the mode in your calculator. I think it's the second or third down, and just make sure degree is highlighted. Okay, make sure that one is whatever, highlighted. Okay, so now the cosecant of 120. Now that if you look at your calculator and search as hard as you can, you're not going to find the cosecant, the secant, or the cotangent. So the way that you figure these out in your calculator is pretty straightforward. We know that the cosecant is the reciprocal of sine. So we know that the cosecant of 120 is equal to 1 over the sine of 120. So you simply type that in your calculator. 1 divided by the sine of 120. Hit enter, or you could even use your fraction button. Okay, and then when you do that, it's 1.154, and this is 47, and that's positive. Secant is 1 over cosine, and that's negative 2. And cotangent is 1 over tangent, or sine over cosine, however you want to do it. So in this case, since we have a tangent button, we'll just do that. 1 over tangent of 120, negative 0.5774. I believe I'm right there. If I made any mistakes, you know me, wouldn't be shocking. Okay, so these are what we want to go over when we're doing these. Is notice that these are all the same angle. It's all 120. But notice that sine is the only one that's positive in this spot. So take a second and see if you can figure out which quadrant cosine would be positive in, which quadrant tangent would be positive in, and see how that goes. Okay, so take a pause and pick some angles. So an angle in quadrant 3 would be, say, 240, and do the sine, cosine, and tangent of 240. Which one's positive, which is negative. Do the same thing with quadrant 4. Quadrant 4, say, pick 300 degrees, and quadrant 1, pick like 40. Whatever, it doesn't matter as long as it is there. And which trig functions are positive in those quadrants. Okay, so hopefully you did that and you kind of figured it out. It's interesting, but this is how it works. Okay, which quadrant is the cosine of an angle positive? So the cosine is positive in quadrants 4, but also in quadrant 1. And since cosine is positive in those 2 quadrants, its reciprocal, which is secant, is also positive. Okay, tangent is positive in quadrants 1 and 3. So when you did the 240, tangent of 240 should be positive, but not sine or cosine. And since tangent is positive, so is cotangent. Now we sort of did sine up here. Okay, sine of 120, so sine is positive in quadrants 2 and 1 for sine. And also, since sine is positive in quadrants 2 and 1, so is the cosecant. So we have this, you know, mnemonic device or whatever to remember what quadrants each one of those is positive in. So this is a mnemonic, or I'll tell you the mnemonic in a second, but this is a little graph to show you trig functions, or trig ratios, however you want to do it, that are positive. So here, all of them are positive. Here, sine is positive, but remember, if sine is positive, so is cosecant. Here, in this quadrant here, tangent is positive, and here, cosine. Okay, and we have mnemonic devices like, it goes 1, 2, 3, 4, remember, for all the quadrants. So all students take calculus. There are other ones that are inappropriate to speak, but ask your friends, they'll tell you. So ASTC is there to remind you that all of them are positive in quadrant 1. Only sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine in quadrant 4. So how are we going to use this information? Well, the question is, how aren't we going to use this information? Because this is used everywhere. The first way we're going to do it is finding the 6 trig ratios, but we're going to be given a quadrant and some other information. So if I am in quadrant 3, if we remember our little mnemonic, all students take calculus. We know that in quadrant 3, right here, this is quadrant 3, only tangent is positive. Tangent, and I guess you could say cotangent also, because always the reciprocals go along. Because you're just flipping it, you're not changing its sign. So the quadrant in quadrant 3, if we're going to find all 6 trig ratios, only tangent and cotangent are going to be positive. So I'm going to actually write this down. So I'm going to do, all right, so I have to find sine, cosine, tangent of theta. Then I like to do it this way. Since sine is here, I do cosecant, secant, and cotangent. I like to put the reciprocals right next to each other so that I just flip them and it's easier. So the only ones that are going to be positive are tangent. So tangent's going to be positive, cotangent's going to be positive, and these 4 are going to be negative. I'm going to run out of room, but you know how that works. So, all right. So I like to put those signs there. Let's just highlight these signs a little so that I don't have to think about them after. Okay, so the quadrant that we're in tells us the sign of the trig function, and then from there we just do the same thing we've been doing. So here it says the sign is negative 5 over 13, so why don't I just put this in. The cosecant then is just the flip of that, 13 over 5. Now we have to figure out the cotangent and the tangent, or the, in the cosine and the secant. So remember, this is the hidden right triangle. Sine is opposite over hypotenuse. So that's our right triangle. We draw the right triangle out, put a theta wherever you want, except for the right angle. 5 is opposite theta, so here. 13 is the hypotenuse. Do the Pythagorean Theorem. This is a Pythagorean triple, so it is 5 squared plus, we don't know what it is, x squared equals 13 squared. You do all the math. This is 25. Let me just do it fast. Minus 25. X squared is 144. So x is 12. 5, 12, 13 is another Pythagorean triple. And then we just continue on. Cosine is adjacent over hypotenuse. Secant, flip it. And notice the signs are here still, the negative and the negative. So I've got it. Tangent is opposite over adjacent, and cotangent is that flipped. Adjacent over opposite. Sorry about the mess. Let's just... Oh, I thought I picked black. There we go. Okay, that's it. And we're going to do that a few different times, a few different ways. So, what quadrant are we in? That'll tell us all the signs. And then we have to do probably some sort of Pythagorean theorem so that we can figure out the rest of the trig ratios. So, this is a slightly different kind of problem. We're saying we have an angle. Remember, we're always on the coordinate plane. And the angle goes through the point 3, -4. So it goes through this point approximately right there. So we figure we have an angle going through here. I don't know where it is, but there's that angle. We're going to ask what the sine is of that angle, and what the cosine and the tangent. So all 6 trig ratios. So what do we do? What do we do? Well, we form a nice triangle. We just drop this down to the x-axis, and now we have a theta. We have a nice right triangle here. We have a theta right here. Probably should have made that a little bigger. Maybe I can enlarge here. Look at it. Okay, and we have a right triangle. Awesome. We also know that we are in quadrant 3. Nice Paris. We're in quadrant 4, which we know in quadrant 4 only cosine is positive. Okay, remember, because all students take calculus. Okay, so the cosine is positive. We have this nice right triangle. How do we get our sides? Okay, well, this side right here is 3, right, because we went over 3 for the x value. This here is 4, even though my 2 scale is pretty cruddy. This is 4. So now we have a right triangle, and hopefully you all remember the 3, 4, 5 right triangle. We have all of our sides of right triangle. The theta is always here. It's always on the spot made with the x-axis. Okay, that's how we always measure it. We're not over here or anywhere else. It always is dropped to the x-axis, so this is our theta. All right, and then we can figure out our 6 trig ratios. So the first thing I like to do, as I said before, is write them all out. So I have sine, cosine, tangent. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Now we're in quadrant 4. Okay? So in quadrant 4, we know that cosine is positive, so these two guys are going to be positive. Everything else is negative. Okay, we have our 3, 4, 5. Let's just do it. Just do it. It's be super fun. Give in to the peer pressure of trig ratios. All right, opposites over hypotenuse. So this is the angle here. The opposite is your 4. So 4 over the hypotenuse, which is 5. Cosecant, flip it. Cosine is adjacent over hypotenuse. And the secant is your flip. Tangent is opposite over adjacent. Yeah, I don't know where that came from. Hold on, we got that. There we go. Opposite over adjacent. And cotangent, you flip it. Done. So the hard work comes deciding the quadrants, picking what's positive, what's negative. Okay, and then figuring out your sides, your right angle, and taking it from there. Alrighty. So with this last one, you may want to try it on your own, but it does deal with some radicals here and there. So you may want to check your answers at the end or fast forward through my work. It's, as usual. It's up to you. So the cotangent of -2/3. So we know cotangent is -2/3. So we know the tangent, which is the reciprocal of that. Easy one, -3/2. Got half, 1/3 of them done. So then we need sine and cosine, and then we can just flip those two to get cosecant and secant. All right, draw our triangle. We get our theta. Cotangent is adjacent over opposite. If you don't remember those, you do have to go memorize those or take a look at your notes. Okay, so cotangent is adjacent over opposite. So adjacent is between the angle and the right angle. Do the Pythagorean Theorem, and when you do that, you do get radical 13. So then you just put this stuff in. Now we do have to, I usually make sure we're in quadrant 2. So the only thing that's positive in quadrant 2 is sine. So sine and cosecant are positive. Everything else is negative. These already are, so that's good. So sine of theta is opposite over hypotenuse, and the reciprocal of that is radical 13 over 3. Now, we don't particularly like the way this looks, so rationalizing that denominator, multiply the top and the bottom by radical 13, so it's 3 radical 13. Remember, that is just 13. That's it. Okay, the cosine is adjacent over hypotenuse, and just flip it and you get this one. I like to flip before I rationalize because it's easier. So I think I forgot the negative up here, but remember these two guys. Oh no, that's not a negative. You didn't see that. No one saw that. It's not there. Okay, so remember these, sine is positive because we're in quadrant 2. Cosine, secant, cotangent, and tangent are all negative. There you go. Enjoy. Bye-bye.